Hello students, good morning. So we are in the session 2 of work, energy and power. இன்னைக்கு என்னன்னா we'll continue with our discussion. Already we were in the discussion of the calculation of work due to force, work due to constant force. அதை நம்ம முடிச்சிருக்கோம். We will start with work due to the variable force. ஓகேவா? So how do we calculate work due to the variable force? பாருங்க, in case the variable force என்னாகும், the force value can be changing in terms of magnitude change agala, or it can be changing in terms of the direction, or it can be changing in terms of both the values. Okay, அப்படி இருந்தா then how do we calculate the work? இங்க என்ன தெரியுமா, we will not be able to directly calculate the work for the entire journey. இப்போ பாருங்க, A ல இருந்து it is moving up to B ன்னு வெச்சுக்கோங்க. We will not be able to calculate the work for the entire journey. அப்படியே ஒரே ஷாட் நம்ம calculate பண்ண முடியாது. எப்படி பண்ணலாம்? If you look at the journey in terms of small steps, ஒரு small step wise நம்ம பார்த்தோம்னு வெச்சுக்கோங்க, then what happens is, if you consider small displacement, ஒரு இடத்துல you just take a very small displacement. How much small? Differentially small displacement. அப்படி நம்ம எடுத்தா, then for that, because the differentially small displacement will be happening in a very small time. அப்ப என்ன தெரியுமா, அந்த particular value of displacementல we can take the force to be almost constant. ஏன்னா ஒரு differentially small displacement means what? It will be almost close to zero தானா? அதுதான differential. See, generally நம்ம இந்த differential element and சொன்னா what is that? It's a very small value, almost close to zero. Okay, அந்த மாதிரி ஒரு displacement எடுத்தா, then the corresponding force, அந்த டைம் குள்ள இருக்கிற force value will be what? Almost constant தானா? So for that small displacement, work will be given by what? Same, நம்ம இதுக்கு முன்னாடி எடுத்த ஃபார்முலா மாதிரி தான். என்னது? force into இங்க இருக்கிற displacement into cos theta. So இங்க theta என்ன? The angle between the force and the displacement at that instant. Okay, இதுல ஒரு பாயிண்ட் என்ன தெரியுமா, theta can also change with respect to time. என்னது? theta can also change with respect to time. theta ஓட வேல்யூ சேஞ்ச் ஆகலாம். So that is why we are calling it as what? Variable force, right? அதனால தான we are calling it as what? Variable force. Okay, if we want to calculate the overall force, அதுக்கு நம்ம என்ன பண்ணணும்? Simply இந்த மாதிரி நம்ம small displacement ஓட இன்டர்வல்ஸ் எடுத்துட்டு அதுல இருந்து வர work அப்படியே ஆட் பண்ணணும். because work is a scalar quantity தானா? so add பண்ணனும் சொன்னா we cannot simply add it like because இதுல இருந்து வர count, right, will be so small displacement. எத்தனை displacements வரும்? we will get infinite number of displacement வரும். அதனால we will not do normal summation கிடையாது. இங்க என்ன வரும்? integration வரும். okay, so overall displacement நம்ம A ல இருந்து B, what is this? integrate பண்ணனும். so integral f into ds into cos theta when we move it from A to B. அப்படி. okay, so இதுல ஒரு particular case என்ன தெரியுமா? in this one particular case is when the force and displacement, they are happening in the same direction. பாருங்க, an object starting from rest ன்னு எடுத்துக்கோங்க. an object starting from rest and is moved by a particular force. அப்ப என்ன ஆகும்? the displacement is going to be happening in the direction of the force only. Force may be variable force, the force ஓட value variable இருக்கலாம், but displacement will keep happening in the direction of the force. அப்ப என்ன தெரியுமா, cos theta ஓட value cos 0 வரும். cos 0 is what? 1. so in that case, right, what will be the work? will be equal to what? integral f ds when the force and motion are in the same direction. Then what is it that we'll have? The cos theta value 1 ஆகும். Because cos 0 will be what? 1, right? So this is the approach. இப்படிதான் நம்ம work done by a variable force calculate பண்ண போறோம். So work done by a variable force நம்ம calculate பண்ணோம்னா what is it that we require? We will be requiring the integration method. Okay. இன்னொரு approach இருக்கா. That is using the graphical அதிலையும் நம்ம we will calculate the work by a variable force. அது எப்படின்னு சொல்லிட்டு we will try to look at it. But அங்க என்னன்னா we have to be given the graph. So graph கொடுத்ததா we will be able to approach using the graphical interpretation method. But இல்லைன்னா what is the general method? The integration approach இருந்தா we will be able to calculate the work by a variable force. ஓகேவா? So இன்னொன்னு format பாருங்க. Say for example force நமக்கு component formula இருக்குன்னு வச்சுக்கோங்க. So what is the component form of a force means? Like we will be given the I component, J component, K component. So force இப்படி நம்ம express பண்ணலாம். F bar can be what? F subscript x into I cap plus F subscript y into J cap plus so Fx is what? I component, Fy is J component, Fz is K component. Displacement நீங்க பாருங்க. இப்போ ஒரு பாயிண்ட்ல இருந்து இன்னொரு பாயிண்ட் நம்ம மூவ்மெண்ட் கொடுத்தா அந்த position of the particular position, right? Coordinates change ஆகும். அதோட x coordinate change ஆகும், y coordinate change ஆகும், z coordinate change ஆகும். Okay. The small change in the x coordinate dx அப்படி நம்ம represent பண்ணலாம். Small change in the y coordinate dy, small change in z coordinate dz. இங்க பாருங்க. That small displacement சொல்லி தெரியுமா? Small displacement will be what? The small displacement along the x axis, அதாவது dx into I cap plus small displacement along the y direction. ஏன்னா நம்ம position shift பண்ணா you will have a component of the displacement along the x axis or I component, அதாவது dx. அந்த மாதிரி you will also have component of the displacement along the y axis, அதாவது dy ஓட value. You will also have a component of the displacement along the z axis, அதாவது dz. ஓகேவா? So the overall displacement can be represented as what? இப்படி நம்ம represent பண்ணலாம். dx into I plus dy into the j plus dz into the k. ஓகேவா? இப்படி நம்ம vector notation represent பண்ணா then what is the overall work done? What is the overall work done? Integral f dot ds, right? F into ds into cos theta and so on. What is it? F dot ds then dot product between the force and the small displacement. அந்த வேல்யூ நம்ம அப்படியே இன்டிகிரேட் பண்ணணும். A ல இருந்து B when you are moving from point A to point B. பாருங்க. இப்போ F அப்படியே நீங்க சப்ஸ்டிட்யூட் பண்ணுங்க. What is it that you are going to get? F is what? Fx into I plus Fy into J plus Fz into K. ஓகேவா? அந்த மாதிரி இது என்னது? ds is what? Dx into I plus dy into J plus dz into K. இங்க பாருங்க. What is this dot product? Dot product சொன்னா what is it? Product of the I components. So fx into dx. அதுக்கப்புறம் product of the j components. Fy into dy. அதுக்கப்புறம் product of the k components. Fz into zz. So இந்த integration நம்ம split பண்ணலாம். எப்படி பாருங்க? தனித்தனியா. fx dx, fy dy, fz dz. ஓகேவா? So இப்படி ஒரு expression வரும். So this is what the work calculation for a variable force using the component form of the force. என்னது? Using the component of the form of the force. இங்கேயும் நம்ம அந்த ரிசல்ட் பத்தி பேசுறோம். என்னது? If the force and displacement are the same direction வச்சுக்கோங்க. If the force and displacement are the same direction. So let us say we take the direction as x axis. என்னது? If force and displacement are in same direction. அப்படி இருந்தா என்ன ஆகும்? If you take the direction as x axis னு வெச்சுக்கோங்க. For example, okay. அப்போ fy ஓட பார்ட் வராது, fz பார்ட் வராது. So வெறும் இந்த fx term மட்டும் வரும். புரியுதா? So if the force and displacement are in the same direction, என்னது? We are taking the direction to be x axis னு வெச்சுக்கோங்க. Then fy ஓட பார்ட் வராது, fz பார்ட் வராது. வெறும் work will be what? Integral fx dx. Integral ஓட லிமிட்ஸ் எப்படி வரும் பாருங்க. Here the variable is in terms of x தானா. So initial point ஓட x coordinate ல இருந்து final point at x coordinate varum. So you have to integrate it from initial point of the x coordinate to final point of the x coordinate. Okay va? Appo integrate panna we'll get what? The work done by the variable force. Okay, so idhula irundhu or example paakalam parunga. This is the kind of question, even in the past year questions la paathalum you will see that some models of questions have come based on this variable force concept. Okay, a force 10 plus 2x acts on a particle in the x direction where F is in Newton and x is in meter. Find the work done by this force during a displacement from x is equal to 0 to x is equal to 2 meter. Inga enna parunga, x is equal to 0 la irundhu we are moving up to x is equal to 2. Displacement eppadi? It is along the x axis ana. And look at the force. What is the force? 10 plus 2x. In the direction irukka? It is in the x direction. Means force is also in the same direction. Okay, so inga nama enna calculate panna work. Inga parunga, force is in Newton and x is in meter, which means work will be coming in terms of what? SI unit, which is the joule. Okay va? So ipo parunga, what is it? So here we have the force x component and only the displacement is happening along the x direction, right? So look at this, we can do it like this. Remember, integral fx dx. Force will have only one component, which is the x component. Okay, so limits eppadi varum? X value will be changing from 0 to 2. Okay, so 0 to 2, what is the force of the x component? 10 plus 2x into dx. Okay va? So here force is in the same direction as the, so what is that they're using? This is use pannom. So because the force is only acting along the x direction, right? Fy will be 0, fz is 0. So that's why we have only what? 1 integral fx dx. Adula namakku work value varum. So parunga, so inga the integral 10 plus 2x dx. Appadi nama and integration split pannala. Split panna enna varum? Integral 10 dx plus integral 2x dx varum parunga. Okay, so this is by using the property of the integration. Adukapram integral 10 dx and sonna, what is it? 10 appadiye value varum constant. Integral dx will be what? Paranga, what is integral dx? X. Okay, limit 0 to. Adukapram integral 2x dx. Integral 2x dx evala? X square. Here and x square differentiate panna enna varum? 2x dana. So x square idu appadida 0 to 2 limits. Inga parunga, final limit. So the 10 into 2 minus 0. Okay va? So here final limit of the value is 2, initial limit of the value is 0. Adukapram idanadi x square final limit minus initial limit means what? 2 square minus 0 square. Paranga total enna varudhu solittu, what is it? The final answer we are getting 10 into 2 evala 20 plus idanadi 2 square is what? 4. So evala varudhu paranga 24 joules. Okay va? You guys also check and tell me whether you are getting the same answer or not. And this is an important model question. Already past years on the, so we have to be careful. So it's a very simple thing. When you have a question like this, right? And you will be having, generally you will be having the force which will be in the same direction as the displacement. Okay. What is going to happen? We will get multiple. So what is going to happen? We will get multiple integration terms. Generally we will be having force which is in the same direction as the displacement. Okay, like usually you will be given force along the x-axis and the movement of the particle also will be along the x-axis. Okay, what is it that we need to do? And the force expression we have to substitute in the expression integral f dx avladha. Okay va? So integration பண்ணும்போது we have to be careful about the limits. இதில் என்ன தெரியுமா, we will be usually getting only the standard integrations. Okay, so ரொம்ப காம்ப்ளெக்ஸான integration expressions அதெல்லாம் வராது. You will be having only what very simple integration like in the integral dx, integral 2x dx அந்த மாதிரி தான் வரும். Okay, so இதில் என்ன தெரியுமா, we have a very standard result for all these algebraic or exponential things, right? And the integral x power n dx will be what, x power n plus 1 by n plus 1. Okay va? In the formula நம்ம ஞாபகம் வச்சுக்கணும். இந்த மாதிரி we have one more thing, integral dx by x, அது என்னது, ln x. ln x ன்னு சொன்னா what is it, log to the base e, natural logarithm. Okay, so இந்த மாதிரி basic integration results we should be comfortable. Okay, so அடுத்தது என்னன்னா, when we have a variable force, we can calculate the work by using the graph also. இந்த graph ஓட base பண்ணி we can calculate the work. அது எப்படின்னு பார்க்கலாம். So இங்க என்ன தெரியுமா, we should be given the graph first of all. graph கொடுக்கலன்னா இந்த approach நம்ம proceed பண்ண முடியாது. So graph na we should be given, இங்க பாருங்க, if say for example force is along the x direction, force is along the x direction, இதுக்கு முன்னாடி நம்ம பார்த்த கேஸ். Okay, and the displacement is also along the x direction, means force and displacement in the same direction. அப்படி இருந்தா பாருங்க, if they are giving us the force value with respect to the x coordinate, if they are giving us எப்படி, how that force is changing with respect to the position, with respect to the position. Okay, இங்க என்ன தெரியுமா, let us say the graph is like this, இப்படி தான் வெச்சுக்கோங்க. Then if you want to calculate what is the work done when you take the point from இங்க என்னது xi ன்னு சொல்லலாம், இது என்னது xf, the initial point ல இருந்து final point. Okay, so initial point ல இருந்து நம்ம final point கிட்ட போனா what is the work that is done by the variable force. இங்க என்ன தெரியுமா, first look at this normal and the integration expression என்னது, integral f dx இதுதானா. So initial limit to final limit, what is it, integral f dx அதுதானா. So இங்க பாருங்க, what is f dx means, for dx ன்னு சொன்னா what is it, small change in the position அதுதானா. what is dx means, small change in the position. இங்க பாருங்க, we take a very small change in the position, இங்க ஒரு small change in the position dx எடுக்கலாம். அங்க இருக்கிற force value என்ன, f. Okay, so இந்த ரெண்டு values நம்ம multiply பண்ணா what is it, அதுல இருந்து என்ன வருது பாருங்க, f ஓட நம்ம இந்த dx multiply பண்ணா என்ன வருது, we are getting அந்த small rectangle மாதிரி வருது பாருங்க, small rectangle ஓட ஏரியா, அப்படிதானா. so இது நம்ம என்ன பண்றோம், we are just trying to add it up. integrate ன்னு சொன்னா what is it, addition தானா. so இப்படியே we are trying to add up all these f dx values, means what, we are trying to add up all these rectangle areas, அப்படிதானா. we are trying to add up all these rectangle areas. நீங்க இந்த எல்லா rectangle areas add பண்ணா என்ன வரும், what is it that we are going to get, இதுல என்ன வரும், we are going to get what is the area between the force curve and the x axis. x axis சொன்னா what is it, position axis. Okay, இங்க என்ன தெரியுமா, the x axis must be what, representing the position. என்னது, the x axis must be representing the position. Okay வா. so இப்படி தான் நம்ம graphically we can calculate the work. so how we can calculate the work by using graph, the integration ஓட graphical significance என்ன தெரியுமா, area between the curve and the x axis. so பாருங்க, if you want to find the work done by the variable force when you displace it from initial point to final point, எப்படி, how do you calculate the work, we have to just take the area between the force curve and the x axis. அந்த ஏரியாவோட வேல்யூ தான் the work representation. so the area will be representing what, the work done by this variable force. இங்க என்ன தெரியுமா, we have one more important thing, like already in the graph based questions நம்ம பார்த்திருக்கோம் in kinematics. sometimes என்ன ஆகலாம், we can have the graph which is going below the x axis also. பாருங்க, so for example இப்போ initial point இங்க இருக்குன்னு வெச்சுக்கோங்க, initial final point இங்க இருக்கு. okay, இதுல என்ன தெரியுமா, we can have sometimes the graph going below the x axis. அப்ப என்ன பண்ணணும் பாருங்க, when you take the area, right, area below the x-axis. இங்க பாருங்க என்ன வருதுன்னு சொல்லிட்டு we are getting area above the x-axis and the area below the x-axis. Area below will be taken as a negative work. எப்படி area below will be taken as what? Negative work. ஏன் தெரியுமா? பாருங்க, if you take force in one direction as positive, other direction force will be what? Negative தானா? Because here we are having force and the change in position. If the force in one direction we take it positive வெச்சுக்கோங்க, இங்க ஒரு direction இருந்தா we'll take it negative. அதனால என்ன? The work done by this other side force, right, will be what? Negative. பாருங்க, we are talking about the displacement along the x direction, positive x direction. If the force is along the positive x direction, என்ன ஆகும்? Work will be positive. அப்படி இல்லாம if the force is along the negative x direction, so apparently the work will be what? Negative dana. So this is how we are going to get the area will be what? Representing work done which will be negative. Why negative? Because the force will be in a different orientation. அதனால என்ன தெரியுமா? So இந்த மாதிரி ஒரு situationல பாருங்க, if say for example we are getting இங்க இருந்து area A1, இதோட area A2, இதோட area A3. இப்போ என்ன தெரியுமா? The overall work done will be given by what? A1 minus A2 plus A3. So அந்த வேல்யூ மட்டும் நம்ம subtract பண்ணணும். புரியுதா? So the work done when the graph, so பாருங்க, this is what? W1 plus W2 plus W3. So total work done சொன்னா what is it? W1 plus W2 plus W3. But W2 oda value, right? What is the W2 oda value? We are taking it as what? Minus A2. So எங்க அந்த force curve graph x-axis ஓட கீழ போறதோ, there we have to take the area to be what? Negative எடுக்கணும். Okay, so the area between the force curve and the position axis gives us what? Work. This is an important point. If the area is above the x-axis, work will be what? Plus and the area of the value. If the curve is going below the x-axis, work will be what? Minus the area of the curve. Okay, va? So apadi nama calculate panna. So this is how we will be able to calculate the work done using the graphical interpretation. Okay, idhil enna theriyuma? Usually we will be given the same case nu sonna force will be in say for example x-axis oda idhile irukku vechukonga, then they will be representing the displacement also in terms of the change in the x coordinate and the madri da varum. Okay, but you want to calculate the overall work done in a general case nu vechukonga. General case nu sonna enadhi? The force will be having the x coordinate and the madri force will be having the y coordinate, then force also will have the z coordinate. And general displacement is sonna the displacement of the particle can be having the x component, it can be having the y component, it can be having the z component. Ella components varala. அப்ப என்ன தெரியுமா? We are going to get three graphs அவ்வளவுதான். See, already work expression நம்ம கிட்ட இருக்கு. என்னது பாருங்க, integral a to b fx dx. அப்படிதானா? தனித்தனியா நம்ம ஸ்ப்ளிட் பண்ணிருக்கோம். integral a to b fy dy. அதுக்கு அப்புறம் integral a to b fz dz. So இப்போ என்ன ஒரு பாருங்க, we have to take three graphs. fx how it is changing with respect to x coordinate. அதுக்கு அப்புறம் fy how it is changing with respect to y coordinate. fz how it is changing with respect to z coordinate. The மூணு இதுல இருந்து we will get the area. So இதுல இருந்து என்ன? We will get the first term. இங்கல இருந்து என்ன வரும்? We will get the second term. இங்கல இருந்து we will get the third term. But maximum caseல என்ன தெரியுமா? இந்த ஒரு மாடல் நமக்கு வராது. We will get only this particular case. என்னது? The force will be along one direction, which is the direction of the displacement. Okay, usually they will be giving us what? Force to be along the x-axis and the displacement or change in position will be also along the x-axis. Okay, va? So we look at a question, right? So this is a question that has come in the 2005. Paranga, a force F acting on an object varies with a distance x as shown in the figure. Paranga. So the force is changing with respect to the distance or the position. Okay. The force is in Newton and x is in meter. So both are in the SI system of unit. Okay, va? the work done by the force in moving the object from x is equal to 0 and x is equal to 6 பாருங்க x is equal to 0 ன்னு சொன்னா what is it, the starting point, x is equal to 6 எங்க இருக்கு. So x is equal to 0 and x is equal to 6 வரைக்கும் நம்ம மூவ் பண்ணா what is the work done எப்படி வரும், just area between the force curve and the x axis அவ்வளவுதானா. இங்க பாருங்க, so area between the force curve and the x axis. So here if you observe it right, இது நம்ம ரெண்டா ஸ்ப்ளிட் பண்ணலாம். So பாருங்க, first is like what, ஒரு rectangle மாதிரி, இன்னொன்னு second part is like what, triangle. So first part is what, area of the rectangle. பாருங்க, what is the area of the rectangle, height எவ்வளவு 3 newtons, width 0 to 3 meters, ஓகேவா. So what is the area, 3 newtons into 3 meter, then it is 9 joules வரும். That is the area of the first part. Okay, அதுக்கப்புறம் look at the area of the second part, right. Second part area பாருங்க, second part area எவ்வளவு, we have the triangle here. So triangle area formula என்னது, half into base எவ்வளவு 3 ல இருந்து up to 6, which is what, இது என்னது 3 meters, ஓகேவா. So 3 meters into height same தானா. So the height of the rectangle is same as the height of the triangle. So height எவ்வளவு பாருங்க 3 newtons. So half into 9, which is what, 4.5 joules. So we are looking for what, total work done. So total work done means what, the work in the first case plus work in the second part. Okay, what is it, 9 joules plus 4.5 joules. So எவ்வளவு வருது, 9 plus 4.5 எவ்வளவு, 13.5. பாருங்க, what is the answer, option B is the answer. In the movement of the object from x is equal to 0 to x is equal to 6 meter, right. What is the work done by the variable force, அதோட value என்ன, it will be what, 13.5 joules. Okay va. So good Maitri, I think you gave the answer for the previous question. Check பண்ணுங்க, what is the answer for this one. What will be the answer for this one, it will be what, 13.5 joules. Okay va. So இங்க என்ன தெரியுமா, ஒரே ஒரு பாயிண்ட். So wherever the force is going below the x axis, அங்க மட்டும் நம்ம கேர்ஃபுல்லா இருக்கணும். Okay, so sometimes when they are giving us some கொஞ்சம் tricky questions கொடுத்தா, that's the model that they can explore. In a general model, this is a general model, so you will not have complexity. இதுல complexity வராது, you will just have the area between the force curve and the x axis. But கொஞ்சம் complicate பண்ணோம்னா, they will try to take the curve below the x axis. What is the point there, wherever the area we are measuring below the x axis, right, and the corresponding work நம்ம நெகட்டிவா எடுக்கணும், அவ்வளவுதான். ஓகேவா. So this is the approach for finding the work by using the graphical interpretation. So அடுத்தது என்னன்னா, we will try to classify the forces based on the nature of work that they do. எந்த பேசிஸ்ல, based on the nature of the work done. See, types of forces and சொன்னா, what you will think is, sir நம்ம already பார்த்திருக்கோம் இது in the Newton's laws of motion. அங்க தெரியுமா, we talked about the general types of forces based on the source or the origin. இப்போ அங்க தெரியுமா, what is that we said, gravitational force ன்னு சொல்லிருக்கோம். Gravitational force is because of what, because of the attraction between the masses. Particularly any object which is near the surface of the earth will be pulled downwards by the gravitational pull of the earth. Okay, அதுக்கப்புறம் we talked about the tension force, which is because of the elastic properties in the string or the rope. அதுக்கப்புறம் we talked about the spring force, spring குள்ள இருக்கிற force, that is the restoring force, that is also elastic force. அதுக்கப்புறம் we talked about what, the normal reaction, then we talked about the friction. Okay, so இதெல்லாம் தெரியுமா, these are all the way we'll call the forces based on the origin or the source. So எங்கலேருந்து இந்த force generate ஆகுறதுன்னு சொல்லிட்டு on the basisல we try to classify the forces. But இங்க என்ன தெரியுமா, we are going to look at almost நம்ம இதுக்கு முன்னாடி பார்த்த whatever the forces, right, we'll look at only those forces திருப்பி நம்ம பார்க்க போறோம். And we'll try to see what is the nature of the work done by them. இங்க என்னது, we are trying to see what is the nature of the work done by the forces. அதுலேருந்து we'll try to classify the forces into two categories. எத்தனை categories? Two categories. Okay, we'll try to see what is the name of the categories சொல்லிட்டு நம்ம அப்புறம் பார்க்க போறோம். But we'll try to first understand the nature of work done by the common forces. So நமக்கு தெரிஞ்ச whatever the common forces, right, we'll try to understand what is the nature of the work done by them. So first என்ன தெரியுமா, we'll start with one of the very common forces that we are using, என்னது, gravity. So இங்க பாருங்க, there is an object of mass m. If it is close to the surface of the earth, அப்படி நம்ம எடுத்தா, then what is the gravitational force acting on it? mg downwards. அப்படிதானா? It will be what? mg acting downwards. So இங்க பாருங்க, we are trying to move it from point 1 to point 2. இதுல என்ன தெரியுமா, we are giving it a vertical displacement. We are giving a vertical displacement. What is the vertical displacement of the value? Let us say h. Okay, இங்க நம்ம ஏன் vertical displacement ன்னு சொல்றோம், because even if you give displacement in some other direction, so இப்படி இல்லாம, let's say for example we are moving it from here to here, okay, same horizontal, அந்த same level வர மாதிரி we are moving it like this. இங்க என்னது, let us say displacement s ன்னு எடுத்துக்கோங்க. But remember what is the work formula? இங்க என்ன தெரியுமா, we will take the force to be constant value, because g oda value will be almost constant, right? When you take near to the surface of that, g oda value will usually take it as what? Constant. So the gravitational force will take it as a what? Constant force. So constant force work will be what? F into s into cos theta. Cos theta and so now what is it? The angle between the displacement and the force line. இங்க பாருங்க, so s வராது in the work calculation, s varadu. What is going to come? S cos theta varum. What is the s cos theta? It is the component of the displacement along the vertical line. S cos theta, so now what is it? It is the component of the displacement along the vertical line. Okay va? So we will not be considering the general displacement when you are trying to calculate the work done by the gravity, right? We should always take the vertical displacement. Okay, so vertical displacement is other than the straight, we will get the work by the gravitational force. இங்க பாருங்க, we are trying to move it from point 1 to point 2, அப்படியே vertically upwards. Displacement எவ்வளவு? What is the displacement here பாருங்க? So displacement இது என்னது? h upwards. Okay வா? And what is the gravitational force? Gravitational force is always downwards தானா? What is the value? mg downwards. இங்க பாருங்க, we are taking it by a height h ன்னு வெச்சுக்கோங்க. Then what is the angle between the force and the corresponding displacement? இப்போ displacement எந்த பக்கம் இருக்கு? It is upwards. Force is downwards. So what is the angle between them? 180. So பாருங்க, work done by the gravity when you take it from 1 to 2. Okay, so work done by the gravity when you take it from 1 to 2. So point 1 we are taking it to point 2, right? So work done by the gravity will be what? Force mg into displacement h. What is the angle between them? 180 degrees. So into cos 180. What is cos 180 value? -1 dana. So what is it? Minus mgh. So நம்ம point 1 இருந்து point 2 கிட்ட நம்ம எடுத்துட்டு போனா, then what is the work done by gravity? Work done by gravity is what? Negative. So இதுல ஒரு important significant point என்ன தெரியுமா? When you are moving any object vertically upwards, then work done by gravity will be what? Negative. Yeah, why is it negative? Because gravity is a force acting downwards. இங்க எப்படி இருக்கா? We are giving a displacement in opposite direction to the force. அதனால the work done by gravity will be what? Negative. Okay வா? If you bring it from 2 to 1, அப்படியே நம்ம reverse. Point 2 இருந்து point 1. We are bringing it from 2 to 1. இங்க என்ன தெரியுமா, we are giving it a displacement which is same value h but downwards. What is the gravitational force? Downwards ana. What is the gravitational force? We are trying to look at what is the work done by the gravity. Okay, so gravitational force, it will be what, always downwards only. Then what is the work in this case? Point 2 we are moving it up to 0.1. So work will be what? Force into displacement into, what is the angle between the force and displacement? Displacement downwards, force is also downwards. Adhanala the angle between them is what? 0 dana. So which is what? Cos 0 varum. So what is this? mgh. So idhula irundhu vara conclusion enna theriyuma, இந்த values மட்டும் நீங்க நோட் பண்ணிக்கோங்க, because we will use them in our further discussion. Okay, so once we talk about the classification of the types of forces, right, அதுக்கப்புறம் we are going to use these two results, திருப்பி நம்ம இந்த values யூஸ் பண்ண போறோம். Okay, so இங்க இருந்து வர மெசேஜ் என்ன பாருங்க, if you look at work done by gravity, நம்ம ஒரு ஆப்ஜெக்ட் மேல எடுத்துட்டு போனா, which means what, you are trying to give a upward displacement or vertically upward displacement, அப்ப என்னது, work done by gravity will be negative. If you are moving an object downwards, then work done by gravity will be what? Positive. A simple reason, என்னது, gravity is a force acting downwards. நீங்க அந்த டைரக்ஷன்ல நீங்க டிஸ்பிளேஸ்மென்ட் கொடுத்தா it will be what? Positive work. Displacement is the opposite direction இருந்தா what is it? Work will be negative automatically. Okay va? So this is about work done by gravity. So என்ன தெரியுமா, gravity can do positive work, gravity can do negative work, and gravity can also do zero work. எப்போ, so if say for example நம்ம ஒரு ஆப்ஜெக்ட் அப்படியே ஹோல்ட் பண்ணி we are moving in the horizontal direction வெச்சுக்கோங்க, இதுக்கு முன்னாடி நம்ம பார்த்த மாதிரி ஒரு எக்ஸாம்பிள். ஸோ இங்க பாருங்க, there is a person, he is holding some object, அப்படியே he is moving in the horizontal direction. இங்க பாருங்க, gravity is acting on that object, right? Gravity எப்படி ஆக்ட் ஆகும்? Downwards. The object is moving horizontal, so which means displacement எப்படி இருக்கு? Horizontal. So the gravity is downwards, displacement is horizontal. What is the angle between them? And the rendu nodula, what is the angle between the 90 degrees dana? So which means in that case work done by gravity will be what? 0. So gravity can do positive work, gravity can do negative work, and the madri gravity can also do zero work. Okay va? Adutha parunga, this is another important, work done by the normal reaction for a body moving along a plane. So again theriyuma, we are looking at a body which is moving along a plane. Moving along a plane nu sonna idhula nariya examples nam edukala, like we can have an object moving along a horizontal plane, and the madri we can also have an object which is moving along a inclined plane. So plane and sonna we can talk about what? Different types of planes, right? Then the inclined plane, what is this? Horizontal plane. We can have the plane to be vertical also, nariya vidhama nam edukala. Okay, so but we will just look at some cases. Inga enna theriyuma, the displacement is happening along the plane. Inga padha, displacement is happening along the plane. Okay, if the displacement is happening along the plane, why displacement happens along the plane? Because the body or that object is moving along the plane and sonna paranga, we are having an object which is moving along the horizontal plane. And the madri or situation nam edutha, what is the displacement or direction going to be? Displacement is going to be along the horizontal dana. If you are moving an object along the inclined plane, apana the displacement will be also along the inclined plane. Maybe it may be down the plane or it may be upwards the plane, but it will be what? Still along the plane. Okay, ipo enna theriyuma, paranga, if we are looking at the normal reaction, normal reaction eppadi irukum? It will be acting perpendicular to the plane dana. So inga eppadi contact plane ipdi iruka, so normal reaction is acting perpendicular to plane. Inga paranga, what will be the work done? What will be the work done here? So the angle between them is what? Normal reaction and the displacement, right? What is the angle between them? 90. If the angle is 90 means what will be the work done? 0 dana. If the angle is 90 means work done evlo 0 dana. Inge paranga, So normal reaction எப்படி வரும்? Normal to the contact plane தானா? So இங்க என்னது பாருங்க, what is the angle between the normal reaction and displacement? 90. அதனால என்ன, the work done by the normal reaction is what? 0. Work done by the normal reaction எவ்வளவு? 0. But நம்ம எல்லா கேஸ்லயும் இப்படி வரும்னு சொல்ல முடியாது. It will be when the movement of that body is along the contact plane, then the work done by the normal reaction will be 0. But if the movement of the body is not along the contact plane, if the movement of the body is not along the contact plane, then work done by the normal reaction will have some other value. அதுக்கு நான் ஒரு simple example காமிக்கிறேன். Okay, so if we look at the movement of the body which is not along the contact plane. So what is that we've taken? We have taken the work done by normal reaction for a body moving along the plane. Okay, let's say general case, work done by a normal reaction for a body. So I will take you to that the lift, person standing in lift. An example we discuss பண்ணிருக்கோம். ஞாபகம் இருக்கா? So the concept of the apparent weight. Okay, so இங்க பாருங்க, if you look at the lift which is going up or going down. Okay, so இங்க என்ன ஒரு normal reaction இருக்கும், அந்த மாதிரி there will be the weight on that person, right? There will be two forces, normal reaction act ஆகும், அந்த மாதிரி weight. If there is a displacement, right, of that lift, either upwards ஆகலாம் or downwards. பாருங்க, what will happen? The displacement, right, will be either along the normal reaction direction or opposite to the normal reaction direction. அப்படிதானா? So இங்க எப்படி இருக்கா? Normal reaction is upwards. So if the lift is moving up means displacement is also in the same direction. If the lift is moving down, up and down, the directions are opposite. But definitely there will be work, right? Definitely there will be some work done. Okay, so work done by normal reaction எல்லா கேசஸ்ல நம்ம ஜீரோன்னு சொல்ல முடியாது. எப்போது ஜீரோ ஆகும்? when the body that you are studying, right, is moving along the contact plane, like an object which is moving on the horizontal surface or a block which is moving along the inclined plane. அந்த மாதிரி கேசஸ்ல தான் the work done will be what? Zero by the normal reaction. Okay, but if you look at these kind of cases, இந்த மாதிரி கேசஸ்ல என்ன ஆகும்? You can have work done by the normal reaction. ஓகேவா? ஸோ அதனால நம்ம என்ன சொல்லியிருக்கோம், ஃபர்ஸ்ட் அந்த பாயிண்ட்லேயே நம்ம சொல்லியிருக்கோம் என்னது? work done by normal reaction for a body which is moving along the plane. Okay, அப்படி ஒரு கேஸ் நம்ம எடுத்தா அதில் என்ன வரும்? the work done by normal reaction will be 0. அப்படி இல்லைன்னா then the general motion that you are seeing like this, right, இந்த மாதிரி கேஸில் என்னது? you can have work done by the normal reaction also. ஓகேவா? அடுத்தது என்ன? work done by the tension force. Tension is what? The force acting due to a rope or a string. அதுதானா tension என்னது? It is the force acting due to the rope or a string. பாருங்க, we are attaching a rope or a string to a body. Okay, so tension will be always acting into the rope dana. Tension will be always acting into the rope. We can have the displacement which is along the tension force, or we can have cases where displacement is opposite to tension force. அதுக்கு ஒரு best example என்ன தெரியுமா? So we have talked about this pulley and masses. ஞாபகம் இருக்கா? So if we are having two masses, m1 in the bakka, m2 in the bakka, we have even derived the acceleration of that. இப்படி ஒரு system இருந்தா what is it? Acceleration of this arrangement is what? அதோட simplified formula என்னது? m2 minus m1 by m2 plus m1 into g. இதுதானா? So m2 we are taking as the higher mass. இங்க பாருங்க, இந்த மாதிரி situationல what happens? m2 will be going down, m1 will be going up. So m2 க்கு மேல பாருங்க, what is the tension force acting on m2? Upwards, but displacement எப்படி? Downwards. So இங்க நீங்க calculate பண்ணா what is it that you going to get? Work done by tension on the m2 will be what? Negative வரும். ஏன்னா the direction of the tension force and the displacement are in opposite. M1 oda case la parunga, M1 is what? Tension is acting on it upwards. And tension, the rendu masses ku mela tension will be always acting into the rope dana. Tension is acting upwards. Okay. Displacement eppadi? Adu upward dana. Which means what? In this case of M2, work done by tension is negative. In the case of work done by tension is what? Positive. But work done by tension can be zero also sometimes. If you are just hanging a block by using a rope, then there is a tension force acting on the body. Tension will be there, right? Tension is going to balance the weight. So if you are hanging a block by using a rope, tension will be balancing the weight of the block. But in displacement, the block is hanging means what? It is not having a displacement. So work done by the tension will be zero. So what is the message? Work done by tension can be positive when the displacement is along the tension force. Work done by tension can be negative when the displacement is the opposite side. And work done by tension can be also zero. And displacement, then what is the work done going to be? Tension force, there can be the tension force, but work will be zero if there is no displacement. Displacement, then work will be what? Zero. Okay, wow. So these are the kind of situations we can have for the work done by the tension force. Another common force is friction. Friction, and we will generally talk about either static friction, kinetic friction. Okay, paranga, we'll first start with the static friction. Okay, so if say for example there is an object in vechkonga, static friction eppo act agum? Static friction, when it will be acting? When there is no relative motion. Appadana static friction eppo exists agum? When there is no relative motion. Relative motion illana, what is it? Displacement over zero. Relative motion illana, what is the displacement going to be? Zero. Correct. So displacement is zero means work done by the static friction zero. Displacement illana, then what is the work done by the static friction? Zero. But it will not be always correct. What is it? You are having an object which is lying on the floor or something. On the object there will be static friction acting. And relative motion, what is the force that is acting? Static friction. So friction is there, but relative motion, which means we are observing that in the object of the displacement is what? Zero. Then since the displacement is zero, work done by static friction will be what? Zero. But we can have work done by static friction in some particular cases. If you take a car, okay, in the example I'm already discussed pannirkom. On that car there is an object. There is a car, on that there is an object. Okay, the car is moving forward. The car is moving forward. So okay, the force an object is at rest with respect to the car, and so now what is it? The force acting on this will be what? Static friction. So the object is moving along with the car means the force acting on the object car nodal, there is no relative motion. But outside or stationary observer motion study panna, what is it that you are going to see? The object is going to move along with the car. On that object, the static friction will be acting in the forward direction. On that object, right? The static friction will be acting in the forward direction. Adanal the object is moving forward. Okay. So static friction is acting in the forward direction, and there is a displacement also in the forward direction. Static friction is acting in the forward direction, and there is a displacement also in the forward direction. The the work done by static friction will not be 0. So generally in lot of textbooks you will see that work done by static friction is always 0. We'll try to see the statements, okay, but we can also have examples where the static friction can also do work. In the Madri case, if you're having a car, on top of the car you're keeping an object. On that object, the static friction will be in the forward direction, and displacement of the object is also in the forward direction, right? So the static friction, we will have some work. Okay, so this is how we'll have the work done by the static friction in the Madri. Okay, after that we look at work done by the kinetic friction. Kinetic friction when there is actually a relative motion between the surfaces. Then only we will get the kinetic friction. Okay, we'll just look at the example. So there is an object which is on a floor. Okay, so we are moving it. A displacement yes, which is toward the right side. So point 1 we are taking up to point 2. Okay, we are moving the object from point 1 to point 2. When our object right side move the frictional force, what is the kinetic friction value? Mu k into normal reaction. So kinetic friction will be acting in the left side direction. So what is the angle between the force and the displacement? 180 degrees. Adanal the work done by the kinetic friction, point 1 and the point 2. We take it from point 1 to point 2. So what is the work done by the kinetic friction? Frictional force into displacement into cos 180. So what is it? Mu k into normal reaction into s into minus 1, which is what? Minus mu k into normal reaction into s. Okay, so what is the observation here? The kinetic friction one direction move kinetic friction will be in the opposite direction. So if relative motion is towards the right side, then the kinetic friction acting on that object will be towards the left. Other than we will have the force and the displacement to be in the opposite direction. So what we can say generally, kinetic friction work done will be negative. Generally we can say kinetic friction work done will be what? Negative. But the work is always relative. Work is always what? Relative. Okay, means what? If we change the observer, in the particular situation we are considering the observer to be what? Stationary observer who is standing outside and observing it. But if you change the observer, right, you can have, you can have work done by the kinetic friction also coming positive. When you change the observer, you can have work done by the kinetic friction also 0. So generally what is it that we say? We'll say work done by the kinetic friction is negative. Like on the static friction case, generally we'll say work done by the static friction is 0. That's a general statement. But other than static friction also can do some work. In case of kinetic friction, generally we'll say what? The work done by the kinetic friction is negative. But we should keep in mind that work is always what? Dependent upon the observer. Observer will depend on. So same kinetic friction also we can have work observed as positive value or work observed as 0. It depends upon the observer. Okay, so it depends upon who is the observer. Okay, so okay, this is about the work done by the friction. So we talked about work done by the static friction and the work done by the kinetic friction. We'll just look at the types of forces. So we'll divide the force into 2 categories. What are the 2 categories? One, conservative forces. Second is what? Non-conservative forces. The classification based upon the nature of work done by the forces. In the basis we in the classification pandrom based on the nature of work done by the forces. Nature of work done by the forces we look at the actual definition of the conservative force. Okay, paranga, what is the conservative force? Conservative force and what is it? A conservative force, right? Work done by the force in a closed path or a loop will be zero. Paranga, ஒரு பாயிண்ட்ல இருந்து நம்ம ஸ்டார்ட் பண்ணி we will go in a path. திருப்பி நம்ம அந்த பாயிண்ட் தான் வந்திருக்கும். So we are starting from a point and we are coming back to the same point. அப்ப நம்ம என்ன சொல்லுவோம்? We'll say it is the closed loop then or a closed path. So if you take a closed loop or a closed path, the work done by the force, suppose there is a force, work done by the force is zero. அப்படி வந்தா then what is it? That force is going to be called as what? Conservative force. So this is the condition. What is the condition for conservative force? இப்போ ஒரு force நம்ம conservative force ன்னு சொல்லணும்னு வெச்சுக்கோங்க, then what is the basis? அதுக்கு what is the basis? If you take a closed loop or a closed path, எடுத்தா work done by the conservative force will be zero. அப்படி ஆகலன்னா what is it? That will be called as a non-conservative force. அவ்வளவுதான், simple. So if you take a closed loop, work done by the closed loop is zero ன்னு வெச்சுக்கோங்க, then that will be what? It will be a conservative force. If the work done is not zero means it will be what? Non-conservative force. That's the difference. இங்க என்ன தெரியுமா? We have some of the conservative forces. இங்க பாருங்க, we look at some conservative forces that we have in our syllabus, plus 1 plus 2 syllabus la. Okay, so what is it? பாருங்க, electrostatic force, the plus 2 syllabus la varum. Gravitational force, it will come in the plus 1 syllabus. Elastic force la enna, we look at the special case of the spring force. Generally elastic force and sonna nariya idhe varum, examples varum, but idhula particularly we look at what? Spring force. Idu nama 11th syllabus la varum. Okay va? Magnetic forces enga, it will come in the 12th syllabus. The rendu will come in the 12th coverage la varum. The gravitational force and the madiri elastic force enga 11th syllabus. Elastic forces la we are not going to cover all the elastic forces. Okay, we are going to only cover what? The spring force. So all these are what? The examples of the conservative force. All these are the examples of conservative force. Next session என்ன தெரியுமா? இப்படி நம்ம ஒரு ஸ்டேட்மெண்ட் மாதிரி கொடுத்து முடிச்சா it's not going to work. We have to see எப்படி, how we are able to say that gravitational force is a conservative force. And it should satisfy the condition, right? ஒரு force conservative force ஆகணும்னா what is the condition for that? Work done in a closed loop should be zero. அதுதான condition. அது எப்படி satisfy ஆகும்னு சொல்லிட்டு we look at it. So we look at what? How the gravitational force is going to become a conservative force. அந்த மாதிரி how the spring force is going to become a conservative force. அது நம்ம பார்க்க போறோம். Okay, அது முடிச்சிட்டு we will go into the important discussion of work energy theorem. And அதுதான் the core of the chapter. So work energy theorem, like how the Newton's laws of motion is entirely depend upon mostly that second law of motion, right? F is equal to ma. And the formula surrounding the entire chapter is decided. So அந்த மாதிரி இங்க என்ன தெரியுமா? The entire chapter will be surrounding that idea. What is that idea? Work energy theorem. Okay, so we look at the proof for how the gravitational force is going to be a conservative force and elastic force is a conservative force. அதுக்கப்புறம் we will go into the discussion of the work energy theorem. Okay va? So we will see in the next class.